I want to find the limit as x approaches infinity of x plus 6 over x plus 1 raised to the x plus 4 power. Okay, so first I'm going to work inside the parentheses. So I'm going to break up the x plus 6. So I can think of that as x plus 1 plus 5 over x plus 1, all raised to the x plus 4 power. Notice that we have x plus 1 here in the numerator and the denominator. So I'm going to break that up. So I'm going to have limit x approaches infinity, x plus 1 over x plus 1, plus 5 over x plus 1, raised to the x plus 4 power. The x plus 1 over x plus 1 is going to turn into 1. So that's 1 plus 5 over x plus 1. And that's going to be raised to the x plus 4 power. Okay. Now, the goal here is to use this fact that the limit as x approaches infinity of 1 plus 1 over x to the x is equal to e. So one thing to notice is that this and this are reciprocals of each other. So if I have 1 plus 5 over x plus 1, I need to have x plus 1 over 5 as the exponent. Okay, so that's what I want to apply to my limit on the left, but I need to raise it to some other exponent. So, because I want to raise it to some exponent so that when I multiply, I get x plus 4. So it's x plus 1 over 5 times my new exponent. I want that to equal x plus 4 when I multiply. Okay, so this is just a simple algebra problem. I'm going to multiply both sides by 5 over x plus 1. And I'm going to put this in parentheses. So then my new exponent better be 5 times x plus 4 over x plus 1. And I'm just going to leave it like this. I don't think that's really necessary to distribute it. And this all works because an exponent to an exponent, you just multiply. So that's why I was multiplying these exponents. Okay, so now I'm going to rewrite my limit with what I have on the right there. So 1 plus 5 over x plus 1 raised to the x plus 1 over 5. And then raise that again to the 5 times quantity x plus 4 over x plus 1. Okay. Now, I don't have it in a nice like 1 plus 1 over x to the x. So to make it look nice, I'm going to let u equal, I'm going to let it equal x plus 1 over 5. Okay. So as x approaches infinity, x plus 1 over 5, that also approaches infinity. So in other words, u approaches infinity as well. Okay, so as x gets big, u gets also big. So then I can rewrite everything. So I guess we could just focus on this part first. So just to keep it simple, I don't want to do too much. So I just want to convince you that this is the same thing as this, which is e. Okay. So in other words, this whole thing is e. Okay. So I showed all that work just to say that's e. Okay, now I'm going to take this and I'm going to say that I'm going to have e limit as x approaches infinity, okay, of 5 times x plus 4 over x plus 1. Okay. So just to rewind a step, I have limit as x approaches infinity of e raised to the 5 times x plus 4 over x plus 1. And then I'm taking this limit on top of the exponent. So the limit, instead of being on the bottom, it's going to go up to the exponent. So that's what I just did there. Okay, and I can divide everything by x. So in other words, multiply by 1 over x. This thing. So I'm going to have e to the limit as x approaches infinity. I'm going to distribute the 1 over x in the parentheses. So I'm going to have 1 plus 4 over x all over 1 plus 1 over x. Okay, so that distributes. Finally, we know that 4 over x goes to 0. 1 over x also goes to 0. So the limit at the top is just going to be 5. And so my final limit is e to the 5th power. All right. Next, we're going to be looking at limit as x approaches 0 of 1 plus 5x squared over 1 plus 3x squared raised to the 1 over x squared power. Okay. For this one, I want to use this property. So if the limit as x approaches 0 of f of x raised to the gx, so if we're given this thing, then I can raise everything to the e. Okay, first, e to the natural log x is equal to x. So let's start with that. I'm going to replace x with this whole limit. Okay. So that's going to be e to the ln of limit as x approaches 0 of f of x raised to the gx power. This natural log will come inside the limit. Okay. So the condition there is that it has to be continuous. So we can pull it inside the limit of f of x raised to the gx power. And so the gx will come out in front, okay, because here we know that if we have ln of, let's say, x to the n is going to come out like that. Okay, so the gx here is playing the role of n. So that's going to come out. Come out in front of the ln. Okay, so now we have this. Okay, so this is what I want. So I'm going to rewrite everything with that in mind. Okay, so let's go back to the original problem. Gx was the exponent, so that's going to come out in front. So I'm going to have e raised to the limit as x approaches 0. G of x is my exponent. Ln of whatever is inside the parentheses. So 1 plus 5x squared over 1 plus 3x squared. Okay. So next property I'm going to use is I'm going to say that ln of x minus ln of y is equal to ln of x divided by y. Okay. So here I'm given ln of x divided by y, and that's going to be ln of x minus ln of y. So I'm going to subtract those. So it's 1 plus 5x squared, and then minus ln 1 plus 3x squared. Okay, so this 1 over x squared is going to distribute to both natural log pieces. So it'll be ln of 1 plus 5x squared over x squared minus ln of 1 plus 3x squared over x squared. The next step, I'm going to multiply the top and the bottom by 5. Because essentially there, I'm just multiplying by 1. And so I want to take the limit of each one of these. So here, I'm going to do this on the side. So I'm just going to look at only the exponent. Okay, so for one of them, it was limit as x approaches 0 of 5 times natural log of 1 plus 5x squared divided by 5x squared. And really, I guess I could factor out the 5 on the bottom, but whatever. Let's see. So if I plug in 0, I get natural log of 1, which is 0, and then 0. So I get 0 over 0. Okay. So that's just, I have to use L'Hopital's rule. So I'm going to take the derivative of the top and then derivative of the bottom. So that's going to be 5 over 1 plus 5x squared. Multiply that by the derivative of 1 plus 5x squared. And then the derivative of the bottom is just 10x. Okay, so the 10x's are going to cancel. So this comes down to limit as x approaches 0 of 5 over 1 plus x squared. And plug in x equals 0, I get 5. Similarly, if we look at limit as x approaches 0 of 3 ln of 1 plus 3x squared over 3x squared, I get 0 over 0. So I use L'Hopital's rule. So I have limit x approaches 0, 3 over 1 plus 3x squared times 6x over 6x. And the 6x's cancel. I plug in x equals 0 to get 3. Okay. So hopefully you can see now why I added the 5 and the 3. Because it made the top and the bottom cancel nicely. So if I didn't have the 5x squared here, let's say, it would not cancel as nice, right? So whatever, that step's optional. It's not a big deal. What we show now is that this limit is 5, this limit is 3, so I have e to the 5 minus 3. So I'm just subtracting the exponents, which will just be e squared. And that's my final limit.